Hey, what's up? 4.8. 4.8 is analyzing graphs of polynomial functions. We've talked a lot about this just throughout the chapter, but now we're kind of getting down to the nitty-gritty of it. It says graph this function. We're also going to find the zeros, the intercepts, the end behavior, the maximums and minimums, and where it's increasing and decreasing. So everything you need to know for the test is going to be here. So the first thing we're going to look at are the zeros. And the zeros right here, that 0 right there gives us that x equals 2. And because that one occurs only once, that means we cross at that 0. And then also x plus 3 is going to be 0, so x equals negative 3. And because that one happens twice, we're going to bounce at that 0. Okay. If you didn't know that, you could always plug that into your graphing calculator and see that. But we know that x equals 2 is a 0, and then we've got 1 at negative 3 right there. Okay. We know that one crosses and one bounces. We don't want to draw anything quite yet, though, just because we don't know really which way our graph is going to go. So those are the zeros. Let's talk about the y-intercepts now. Okay, the y-intercept happens when you plug in 0 for x. So I would just go to your calculator and do that. Plug in 0 for that. So 0.25 or 1/4 times 0 minus 2 times 0 plus 3 squared. Negative 4.5. Fantastic. The y-intercept is at 0, comma, negative 4.5. So we go down right there. Okay, now we still don't want to draw anything quite yet. Just label all your points and then we'll draw it in the end. Okay, let's talk about end behavior. The end behavior here, okay, we've got a degree 3 because there's one x here and there's 2 there. All right, so it's a third degree polynomial. So that means that we're going opposite directions, and our leading coefficient is positive. So that means that we're going to go down, then up with our arrows. So now this is how we write it. F of x approaches something as x approaches negative infinity, and f of x approaches something, it happens to be that, as x approaches positive infinity. Okay, so it's going to look something like that. Okay, so f of x is getting smaller and smaller and smaller as x is getting smaller and smaller and smaller. Okay, and then f of x is going to get bigger and bigger and bigger as x gets bigger. Okay, so end behavior. You can draw the arrows if you like, but just be aware that on the test you are expected to write it like this. Okay. Okay, great. So we know a couple things here. We know that this is going one of the 3 bounces. This one bounces. So now that we know the end behavior, we know that that's going to bounce and go back down. We know that we cross at this one, so it's going to look something like that. Okay, but what we don't know is what happens in between. So now what we need to do, okay, let's go ahead and graph it just so we can see what it looks like here. Let's do 0.25 times x minus 2 times x plus 3 squared. Go to the graph, okay? Here what you're noticing is that it has a maximum and a minimum. Let's find those, okay? So we're interested in where we have a local max and where we have a local minimum, okay? A local maximum is going to occur right there, so let's find that. You could probably see and probably reason that it's going to be that 0, but just in case you didn't know, let's go there and there. Oh, no sign change. That's probably because I did it wrong. We're not looking for a 0. We're looking for a maximum. There we go. Go to the right. Go to the left. Enter, enter. Okay, that maximum is at negative 3. That's a 0. That e to the negative 12 is scientific notation. Okay, so that maximum occurs at that bounce point, which is negative 3. So the maximum occurs at negative 3, comma 0. Okay. The minimum, so let's go back to our graph. The minimum is right there. Let's find it. The minimum, so we find what that minimum value is. Okay. The minimum is going to be 1/3. That's what that is. 1/3 negative 4.63. Okay, so that's the minimum. Okay, so we know that that occurs about right there. Okay, from here we have enough information. Okay, we know that this graph is going to look something like that. And yours might not be perfect, and that's okay. We have graphing calculators, so that's fine. All right. Okay, we're almost done. Let's figure out where this thing is increasing and decreasing. Okay, think of it like the roller coaster, like I said in class. Okay, we are increasing when we're going up the hill. Okay, so we're going up the hill right here, right? If we're traveling, going up the hill. So that means we start at negative infinity until we get to x equals -3. And then we are also increasing from this value all the way up there. Well, that value right there is that minimum value, which is 1/3. And we're going to increase forever and ever and ever. Oops, I wrote it in the wrong spot. Okay? All right. We are decreasing in between. Okay, so where we're decreasing, we start decreasing at -3, and we continue decreasing till we hit that minimum value, which is positive 1/3. Keeping in mind we use open brackets or parentheses when we're talking about minimums or increasing and decreasing, because those points are not you're neither increasing nor decreasing there. Okay, think of it as you're at the top of the roller coaster or the bottom of the roller coaster. You're neither going up nor down. Okay. Hopefully that helps. If not, come see me. I'd love to work with you. See you later.